Had we but world enough and time, this coyness, lady, were no crime. Well, they say it's good to talk to your plants, but until recently, I didn't realize just how good it really was. Shalom, beloved sibling. It is I, Aaron Freeman, not a scientist, but a Sciency optimist, here to hopefully acclimatate to your humors with a bit of Sciency awe. Until recently, I had given very little thought to the significance of talking to, or more importantly, breathing upon plants and trees, until a recent conversation with my ace buddy, physicist Nicholas Gross of Boston University, who asked,
a sequoia tree, giant sequoia tree, hundreds of meters tall. Well, I don't know if it's hundreds of meters tall, but
big.
Hundreds of meters. How does the mass that the tree, that the wood is made out of, get into the tree? Where is it coming from?
The ground is my first thought. That it pulls nutrients from the ground and through the energy provided into its leaves by photosynthesis, converts those nutrients into proteins of which its mass is composed.
That's a good guess.
I know what that means.
Often people say that, but most of the mass of a tree comes from the air, comes from the carbon dioxide in the air.
How does air become wood?
So the bottom line is one of the main components of air is carbon dioxide. Now, even just that statement that I made, one of the main components of air, is not entirely true. Carbon dioxide is only about 4% of our atmospheric composition, but that 4% of all the air floating around us is incredibly important. That carbon dioxide floating around is the basis for all of the carbon-based molecules that we have on land. So
that would, in theory, include you and me.
Absolutely.
Carbon-based life forms, okay.
Plants have special holes in their leaves where they can pull in that carbon dioxide. Then there's an enzyme called rubisco. Rubisco can then grab that carbon dioxide, shuffle it around, and do a couple of really cool biochemical reactions. The bottom line is they can then produce glucose. That glucose, right, which is really just a molecule composed of 6 carbons.
6 carbons, 12 hydrogens, and 6 oxygens.
C6H12O6.
There you go.
Absolutely.
Okay.
We can also take other pieces of that carbon skeleton and we can build proteins, we can build lipids, we can build nucleic acids. So we can start to build molecules once we have the molecular puzzle pieces.
The answer to my question is that plants make and then catabolize glucose.
Yes.
Carbon molecules are good because you can attach them to all sorts of things. They can attach them to each other themselves, and they make long carbon chains, and you can stick all kinds of other stuff to them. And there's clever biochemical processes that do that.
Absolutely. That's a perfect way to sum it up.
Ah, that's totally cool. That's totally cool. That's ultimately cool.
Yeah, right.
Wow, most of the mass of the tree comes from the air. That's completely, utterly, mind-blowingly cool. Thank you immensely much for watching all the way to the end, beloved sibling. I post new Sciency optimistic videos every Monday through Friday. If you enjoyed this one, please smash that like if you're into that sort of thing, and click on the little bell so you will be alerted to all the Sciency optimism to come. I am Aaron Freeman, not a scientist, but a Sciency optimist, hoping that you have a growing appreciation of the world as you continue to science the day. You're welcome.